Take a look at this retail price tag for 25 rupees and 50 paisas, and this measuring tape marked at 1.5 meters. These numbers function using a tiny but critical symbol, the decimal point. It acts as a strict boundary line. On one side, you have complete whole items. On the other side, you have fragmented, broken pieces. Look at the number 5.2. The geography is simple. The 5 sits on the left side of the dot, meaning we have 5 whole parts. The 2 sits on the right side, representing a fraction of a whole. That single dot dictates whether you are dealing with a complete entity or merely a fraction of one. To see how the right side of that boundary works, let's examine the number 7.35. The decimal point creates specific new rooms for these digits. The first position immediately to the right is the tenths place. Notice that THS at the end. We are not talking about tens, but a piece of a whole. The second position to the right is the hundredths place. Again, that THS suffix means we are dealing with an even smaller fraction. When we break this down mathematically, 7.35 is exactly 7 ones plus 3 tenths plus 5 hundredths. Each step to the right puts you in a sequentially smaller room, dictating exactly how tiny the broken pieces of your number are. We can visualize this using a physical object. Think of this solid rectangular bar as one whole chocolate bar. If we divide this bar into 10 equal slices, each part is 1/10. We write that as the fraction 1 over 10 or as the decimal 0.1. Now, if we divide the same whole bar into 100 equal squares, we isolate the hundredths place. One single tiny square is 1 over 100, which translates to the decimal 0.01. Let's scale this up. 7 of those tenth slices is written as 0.7. 25 of those tiny hundredth squares is written as 0.25. Decimals are simply a standardized, faster system to write fractions that are based strictly on multiples of 10. When you need to determine which decimal is larger, like 0.7 and 0.5, your mandatory first step is to stack the numbers vertically and align the decimal points perfectly. With the points aligned, isolate the tenths column. 7 tenths is greater than 5 tenths, making 0.7 the larger number. The real test is comparing 0.35 and 0.53. The common trap here is reading them like the whole numbers, 35 and 53. Do not do that. Pause for a moment. Identify the larger number by focusing only on the tenths place. Because a tenth is structurally larger than a hundredth, the tenths place always overrules the rest of the numbers. 5 tenths beats 3 tenths, so 0.53 is the larger value. Let's lock this in with a rapid-fire test. Question 1. What is the value of the digit 4 in 6.42? It sits right after the decimal point, so the answer is tenths. Question 2. Which is greater, 0.8 or 0.6? Checking that tenths column, 8 is greater than 6, so 0.8 wins. Question 3. Write 1/10 as a decimal. The answer is 0.1. Here is your final summary of the laws of decimals. Left of the point means wholes, right means parts. And when comparing, always check the tenths place first. Screenshot this guide, keep practicing, and see you next time.